Hello, math fans. Welcome to Math Olympiad Academy, your gateway to advanced problem solving and mathematical reasoning. Today, we have a very interesting challenge. Can you find the exact value of this expression? The square root of 28 divided by the sum of the square root of 21 plus the square root of 7, all raised to the power of 12? Before we find the solution, let us start with some basic simplifications of the fraction. We have the square root of 28 divided by the sum of the square root of 21 plus the square root of 7. Notice that the square root of 28 can be written as 2 times the square root of 7, and the square root of 21 can be written as the square root of 3 times the square root of 7. Replacing these values in the fraction, we can factor out the square root of 7. After simplifying by dividing both numerator and denominator by the square root of 7, we obtain the simplified fraction, 2 over the sum of the square root of 3 plus 1. Next, notice that we should multiply both the numerator and the denominator, where the denominator is the sum of the square root of 3 plus 1, by the conjugate, the square root of 3 minus 1, to remove the irrational part from the fraction. Doing this, the fraction becomes 2 times the square root of 3 minus 1 divided by 3 minus 1. Simplifying the denominator, we have 2 times the square root of 3 minus 1 over 2. Finally, simplifying by dividing numerator and denominator by 2, we obtain the result. The fraction simplifies to the square root of 3 minus 1. Now, let us set x equal to the square root of 3 minus 1. This gives us x plus 1 equals the square root of 3. Squaring both sides, we have the square of x plus 1 equals the square of the square root of 3. Expanding the left-hand side, we get x squared plus 2x plus 1 equals 3. Rearranging this equation, we find that x squared equals 2 times 1 minus x, which simplifies to 2 times 2 minus the square root of 3, and finally, x squared equals 4 minus 2 times the square root of 3. Now, let us find x to the power of 4. Using the property that x to the power of 4 equals x squared times x squared, we multiply x squared by itself. Substituting x squared equals 4 minus 2 times the square root of 3, we have x to the power of 4 equals 4 minus 2 times the square root of 3, multiplied by 4 minus 2 times the square root of 3. Carrying out the multiplication, this gives x to the power of 4 equals 28 minus 16 times the square root of 3. Next, let us find x to the power of 8. Using the property that x to the power of 8 equals x to the power of 4 times x to the power of 4, we multiply x to the power of 4 by itself. Substituting x to the power of 4 equals 28 minus 16 times the square root of 3, we have x to the power of 8 equals 28 minus 16 times the square root of 3, multiplied by 28 minus 16 times the square root of 3. Carrying out the multiplication, this gives x to the power of 8 equals 1,552 minus 896 times the square root of 3. Finally, let us calculate x to the power of 12. Using the property that x to the power of 12 equals x to the power of 8 times x to the power of 4, we multiply these two previous results. Substituting the values we found earlier, x to the power of 12 equals x to the power of 8 times x to the power of 4, which is 1,552 minus 896 times the square root of 3, multiplied by 28 minus 16 times the square root of 3. Carrying out the multiplication, we find that x to the power of 12 equals 86,464 minus 49,920 times the square root of 3. So, the value of the square root of 3 minus 1 raised to the power of 12 equals 86,400. 64 minus 49,900, 20 times the square root of 3. Hence, The exact value of the original expression, the square root of 28 divided by the sum of the square root of 21 plus the square root of 7, all raised to the power of 12, is also 86,464 minus 49,920 times the square root of 3. Notice that the square root of 3 is irrational. Now, let us verify our result by comparing the two sides. Our calculated value, the square root of 3 minus 1 raised to the power of 12, equals 86,464 minus 49,920 times the square root of 3, which evaluates approximately to 0.02368. Using the original expression, the square root of 28 divided by the sum of the square root of 21 plus the square root of 7, all raised to the power of 12, we also obtain 0.02368. The values agree, verifying the solution. The tiny difference comes from rounding the square root of 3. This confirms that our solution is correct. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!